Okay, so let's pick up where we left off. We've gone through one video on presentation. So what capabilities does the browser give you to present things to the user? HTML, WASM. No, we didn't talk about WASM. It was HTML and Canvas, and a little bit about WebGL. We talked about scripting. What code can you run on the user's browser? There we talked about JavaScript and WASM. And now we need to talk about kind of the third piece with our browsers, which is transport. How do browsers get data from remote servers? How do they send it back and forth? What capabilities are exposed to your scripting languages? So we'll go over, we'll talk about HTTP, HTTP2, WebSockets, server-sent events. These are all things that live in this realm. And so let's take a look at some of the tasks you might need to do if you have a basic web page. So you're almost definitely going to need to load the initial HTML document. Pretty much every web page is going to start that way. Now that may or may not come from a file. Most of the time it does in some ways. But your browser is going to want to make a call to the remote server to get that initial document. And then once it gets the initial document, the document will usually link in some scripts and images. Then once your page is kind of running, maybe it wants to fetch who the current user is, so we can display up here who the current user is. Maybe it wants to get the friends list or mark a post as like. So all of these things are in this list because they involve communication between the browser, the front end, and the back end. So getting the user's list of friends, usually you're going back to the server and asking for that information. Marking a post as liked, usually you want to go to the server and you want to save that into the server's state so that when other people see the post, they'll see that you marked it as liked. I mean, you could just put a thumbs up icon in the browser without any communication back and forth, but then no one else would see it and that wouldn't be all that exciting. So let's start with what we have. Whenever we're talking about two computers talking to each other, there's a lot of technologies out there, and we're not really going to go into too much detail about most of them, and we're really only going to focus on the ones that we're going to end up using, which is TCP and IP. There's a little bit of TLS and DNS, but basically let's start with IP. IP says, as long as you know the address of the remote computer, then you can send bytes to that remote computer. TCP says, okay, we're going to allow you to establish a connection, and you can send streams of bytes and get streams of bytes back, and you can establish multiple connections to that computer. So we're going to create the concept of a port number to know what type of connection you want to establish. So we have IP addresses and we have port numbers. IP address is kind of a unique identifier for the destination you're talking to. It may or may not be a single machine. In like a load balancing case, you may have multiple machines which are all answering to the same IP address, but it should be unique for a destination. So if I want to go to google.com, there should be a unique IP address that I'm going to be talking to. Speaking of google.com, DNS is a service that maps names to IP addresses. I'm not going to go into a great detail of how these things work. It's good to be aware of them because if you're doing web development, you'll probably have to fiddle with these things at one point or another in your lifetime or career. But basically, I want to go here to google.com. I know that I'm going to make a DNS request to figure out what is the IP address for google.com. I'm going to use the IP and TCP protocols to then communicate with google.com, sending bytes back and forth. There's TLS, also known as SSL. SSL is the older name for it. They're just calling it TLS because it's a bit more of a general name. You'll see HTTPS certificates, things like that. These are all kind of at a low level. This is all below what we're going to go into a great detail here. However, this does introduce all these different concepts. So IP address, port number, we're just going to assume these things are given. TCP is going to introduce the idea of a client and a server. So with TCP, you usually have one end, which is listening for connections, and another end, which is establishing connections. So that's going to definitely be important. Usually, or pretty much always, the web server is the server end, and our browser is going to be the client end that's going to be doing the connecting. TCP connections are two-way. As we're going to see, what we're going to end up using, HTTP is not necessarily two-way. And yeah, so basically this is our axiom. This is what we're just going to start, and assuming this is true, which is if we have an IP address and a port number, we can send bytes and receive bytes. If you want more details into that, that's a whole different lesson series. So we have sending bytes back and forth. We need to be able to do all of these different things, and so we need something here. So we could just say, okay, sending bytes back and forth is what you have. Now go write your scripts and things like that to figure it out, but that's a little bit too generic, or at least it was back in the 90s and 80s. So we decided we needed some kind of protocol here in the middle. And protocol, any kind of protocol, we're really just talking about some rules for how we structure these bytes into messages or some other abstract concept and send it back and forth. So it's just an abstraction to be a little bit nicer to deal with than streams of bytes. And so we want something that we can use to express all of these different operations, and that will map to streams of bytes back and forth. And what we have is HTTP. So if you ever Google for Tim Berners-Lee, you always get these pictures of him when he's old today. So I went ahead and dug around. This is probably about what he looks like when he was inventing HTTP, which is way too preppy, fancy for a developer these days. He would need a full beard and at least a mustache to be respected in the open source development world in the modern days. Anyway, so HTTP is a protocol. It tells us how to take these HTTP requests and HTTP responses and turn them into a series of bytes. It's a little bit unusual in that a lot of protocols that you'll deal with if you do any kind of networking are kind of binary. You're dealing with, okay, the first 4 bytes are the length of the message, and the next 4 bytes are the type of the message, and the 4 bytes after that are blah, blah, blah. HTTP is based on ASCII, and it has things in here like spaces and carriage return line feed to separate different parts of the message. So, for example, there's no limit on how long your method could be. It's just everything up until you hit a space. There's no limit on how long your URL can be. It's everything up until you hit a space, and so on. It was designed that way intentionally to be very simple and something you could even use for Telnet. When this was designed, there were no browsers. There was nothing other than some very crude tools for sending messages back and forth. Even the socket API isn't where the socket API is today. So it was designed to be something that you could very easily take and start using, and it turned out to be easy enough that it really took off. And this is actually HTTP 1.1. HTTP 1.0 was even simpler than this. It didn't have headers, for example. Anyway, so the method is what you want to do. The URL is what you want to do it to. The version we'll just ignore. Headers are any extra information you want to send to the request, and then the entity body is kind of the thing you want to do. So, for example, I want to post some documents, and the entity body in that case would be the document itself. The 4 most common methods you'll see: get, put, post, and delete. Get means I want to get something from the server. Put means I want to put something on the server. Post is kind of loosely interpreted as I want to create something on the server. And delete is I want to remove something from the server. Sometimes you'll see put referred to as update and post referred to as create. It's not an exact mapping, and I don't know that I want to go into the details today about what should be different between them. In reality, there's actually no real enforcement of these. So you could build a HTTP server, you could build your web server so that it did everything with Git. In fact, that was very common back in the early days when browsers were kind of all you had. Don't do that today. Now you want to try and at least kind of make use of these. And we'll talk a little bit more about that later in these slides. So example, telnet, like I said, it was designed to be easy. Here is going to be a test of my typing speed. Telnet is just a really basic protocol for any kind of TCP/IP communication. It will establish a TCP connection, and then whatever you type, it will send to the other side. So telnet ICANN as joke.com, port 80. Oh, I typed backspace. All right, this is going to be a test of my typing skills. Let's try this again. Oh no! All right, one more time. No! See, I also have to be fast because most servers will not allow you to take forever because you're using up resources. I hope I can capitalize that. Ah! Managed to make it off. So I got back 301. Turns out this particular API is only allowed to be exposed via HTTPS, and you can't do HTTPS with Telnet that I know of, so we're going to have to call that good for our example here. But that was the entire request. In fact, I could even take this and I could put it into a file. Maybe not. I've never tried that with Telnet before. But anyway, so like I said, it's kind of weird because it's ASCII. Very simple, very straightforward. So that's HTTP. So how does that solve our problem? Let's go back through the list of things we wanted to do. We want to load an initial HTML document. Well, fine. You just want to get the URL for that document. You want to load some scripts. That's fine. You just go get and you call the script. You want to load some images. Well, it's a get and it's an image. Fetch current user. Get current user. This one is a little different than the other ones because normally when you think of these things, you're thinking of I'm loading some file that's on the remote server. Somewhere they have an HTML file, somewhere they have a JavaScript file, somewhere they have an image file. Fetching the current user, that's usually going to be something that exists either only in memory on the server or in a database somewhere. HTTP doesn't really care. It's all URLs. So we get the URL. It doesn't matter if it's coming from file or if it's coming from a database. And that's a nice thing. Like I said, the HTML document may not come from a file. Maybe it's coming from memory too for some kind of performance reason. Get the user's current list of friends. Well, get friends. Mark a post as liked. Now we'll do something other than get. I probably should come up with some better examples that have a lot more different things. But anyway, so then we'll do a put to michaelpage/post/732/liked. So we want to like post 732. And it's a put. So we're going to update the liked status. And maybe the body will tell us whether we liked it or not. So it could be a true or a false. Very simple JSON document or something like that. So we're all done. Except it turns out one of the major problems with HTTP is it tends to be very generic. Now it's one of its strengths, but it has led to HTTP being used in a lot of different ways. For example, should I use put or post? Different people would argue different things, and you will find websites out there that would use put for what that example I had here. Yeah, marketing and post is liked. You'll find websites that would use put for that. You'll find websites that use post for that. You will find people that will get into screaming arguments over which one they should use. Should I name the URL post/732/liked or action/like post? And then I could put 732 in the body. Both of those could work. Should I use the body itself at all, or could I put it in the URL as query parameters? Like post, question mark. Post ID equals 732, ampersand, liked equals true. If I am using the body, JSON, XML, form parameters, a whole bunch of different choices. I could even use one URL for every single thing I want to do. And in the body, I can list the name of the operation as well as the list of the arguments. And now I have this one URL which transforms my entire entire code base into an HTTP endpoint. This is what SOAP does. SOAP is a term you may have heard. Often you will hear it as SOAP versus REST. You will not hear it so much these days because it kind of died. There was a war back in the early 2000s. Not a real war. This is like the browser wars that we mentioned in the last, which was SOAP versus REST. Maybe between 2000 and 2010. And so SOAP lost, REST won. We'll talk about REST in a minute. SOAP is not seen so much. You will still kind of see it in industry use. It was nice because it kind of said there is one way to do all of these things. But we can talk a little bit more about that. It just wasn't popular. And kind of going along that vein, is HTTP an RPC protocol? So this is a bit of a thought exercise. There's no real meaningful point to this question, but maybe you would get to ask this on an interview. It'd be an interesting question because there's no real great answer. An RPC protocol is a remote procedure call protocol. And the idea behind an RPC protocol, if we remember, HTTP was not designed from a programmer's perspective of writing a server. HTTP was designed by this guy who had this idea of the World Wide Web, and there would be all these documents out there, and it would be like one giant library that everyone can contribute to and edit, kind of a Wikipedia type thing. And so HTTP was designed to enable the World Wide Web and this particular vision of the World Wide Web as this kind of Wikipedia-like structure. An RPC protocol, on the other hand, is designed for the purpose of, I have a code base, I have a bunch of methods, I have a class library, so to speak, that's going to be running on this remote server, and I want to call methods on that remote server from my client. And so if you were going to design a protocol for that purpose, you would obviously set about it a very different way. Normally, you would just have, okay, what's the name of the operation I want to call, and give me a list of the arguments. Maybe you have what's the class I want to call and the name of the operation and then a list of arguments. So there's SOAP, which solves that, gRPC, .NET remoting. There's various RPC protocols. HTTP itself is too generic. If we take these method, URL, version, headers, as we've gone through and seen here, there's a lot of different ways you could transform these things into, I want to call method X on class Y. So I would say that HTTP is not technically an RPC protocol, but you can actually build RPC protocols on top of HTTP if you wanted to. And that's what SOAP is. SOAP is designed to be an RPC protocol that is built on top of HTTP. And actually, you can use SOAP on top of things other than HTTP. But I'm really going on way too much about SOAP, which is kind of dead, and I'm not done yet. So what is REST? REST is a term that got way overused during this war I talked about. And if someone is talking about REST, the only thing you can really safely assume is that they're talking about HTTP and they don't mean SOAP. And that's it. Now, you would find some REST purists who say REST is so much more than that. It's kind of like if you were talking about, I'm going to butcher something here, yoga, and you said, oh, well, it's stretching. And that's, you probably can't even say it's that because there's laughter yoga and things out there. So really you can say yoga is a type of exercise. Whereas if you were to talk about, some kind of yoga master who practices a certain style of yoga, they would say that's not what it is at all. It's this long list of things. So anyway, REST, if you were to ask the REST purist, is a philosophy. And it basically goes back to the original vision of the World Wide Web as one giant set of interconnected documents. And there are these set methods that you could use to update them, and each of the methods has a large number of rules. And they're starting to start using words like idempotent and really talking about the difference between post versus rest, post versus put, and things like that. And anyway, the idea is that APIs are an affront to this vision. So what do I mean by this? So just look at some examples here. From a programmer's perspective, you're very used to naming things like login, add friend, is email in use. A RESTite would say, well, these are not manipulations of this giant collection of documents out there. These sound like methods. And if we create methods for all of these different operations, we're going to end up with infinitely many methods. Why don't you say, instead of login, put the current user? Instead of add friend, you could say post to the friends list. Instead of is email in use, you could get the list of emails matching this name. Logout becomes delete the current user. And so the thing they really hate is SOAP APIs, because SOAP APIs are just one method and it does a bunch of different things and you can get it 50 different ways. And the reason they hate all of this is because they want the web to be this giant collection of documents. And if you put a server out there that just has a single API that can do 50 or 60 different things, then suddenly you have this whole space of the internet that you can browse and you can do all these things on. But in the actual API world, the document world, it's just this single URL that has one single method post, because SOAP does everything with post. And it's just an affront to their worldview. So these RESTites will say that you should not map HTTP to your API. You should map your API to HTTP. And you should follow these rules here. So if you're ever curious what true REST is about, it's about those sorts of things. And you can even go a level further. There's lots of people out there that agree with what I've said so far. And they agree with it. You might say, why? This is unintuitive, and it's going through extra work to have to make sure that your API looks like HTTP. So why should you do that? And they would argue that the reason you want to do this is because it will lead to APIs that are more maintainable and future-proof over time. That's not something you can very easily prove. It's, based on conjecture and philosophy, but the idea is if you have this overarching concept of this, collection of documents, then everything can evolve around that concept. And as long as you stay true to that concept, you'll never become obsolete because you're still part of that concept. And so things are more likely to work in the future. Your API is likely to be better and will stand the test of time. But all of that is kind of soft conjecture. So that's REST. Oh, and I was going to say, you could go even further, start talking about the RESTites. And like I said, most people agree with this. There's some people that will take it even a step further and they'll start talking about things like hate OAS, which is beyond the scope of this here. But they would say things like, you shouldn't go straight to the is in email in use API. You should first go to the first document, which gives you the links to is in email in use, and you have to explore your documents. And okay, it's beyond scope, so I won't go into it. So, what if you don't like it? Tough. From way back when, we had this picture here, which is a terrible picture, but you can obviously tell that this is a browser. This is not host-to-host communication. We're talking about browsers. You don't get to do whatever you want. You get to do what the browser gives you. And the browsers decided we're not going to give you raw socket access to the OS. And when I say you, in this case, I mean scripts. Because if you recall from before, scripts are not trusted. And sockets are too dangerous. In particular, raw access to the OS would be too dangerous. There's nothing particularly dangerous about a two-way stream of bytes, but it was just, you don't have access to the OS, and the browser decided to give you HTTP. And there we go. So you get what you get, and you appreciate it. Training all of our children to be good little Stoics. All right, and the browser uses HTTP. So hopefully this is not too surprising by this point, but there's a number of things you can do in a browser which are automatically going to trigger HTTP requests. When you type in a URL and you press enter, it's going to issue a GET to that URL. When you click on a link, that link has a URL attached to it, and it will issue a GET to that link. when you submit a form, it's going to be either a GET or a POST. A form is part of HTML. It's something you can create. There's actually no way in the browser without using scripts that you can do a put or a delete, but you can do posts with forms. There's a lot of things in HTML, scripts, images, blah, 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 style sheets. Then they'll result in GET requests as well. So if I just fire up google.com, it's actually issuing 60, maybe by the point I took the screenshot, 62 HTTP requests. And actually not all of these are HTTP requests. Some of them are data URLs, but at least 50 HTTP requests just to load the simple google.com web page. You know, this was one HTTP request to get this image. Who knows what all these different HTTP requests were for. And the scripts themselves can issue their own HTTP requests. And how do they do that? So if you're writing a script and you want to make requests to the remote server, you get two interfaces for making HTTP requests. You get one that's called XHR. It's old. The X stands for XML, and it has nothing to do with XML. And you get fetch. It's newer, and it's based on promises instead of callbacks. And yeah, never supported by IE, and it never will be because it came out after IE's end of life. Oh yes, and fetch is quite new. For a long time, all there was XHR. XHR is not just callback based, it's just plain inconvenient and ugly. And so jQuery came out as a easier way to make XHR requests. And Angular has its own way to make XHR requests. And there's at least 5 dozen, probably, maybe not that many. There's a lot of open source libraries you can use and projects and modules and JavaScript code that will wrap XHR with something friendlier. So you may see them out there. Under the hood, if it's running in the browser, it's using XHR or fetch. If it's running on Node on the desktop outside the browser, there are other things. It can just open up raw sockets. It can be doing whatever it wants to be doing. But if it's running in the browser, it's using XHR or fetch. And you have to live within the limitations of those two APIs. Not that there are very many of them. Example. So I have a very simple fetch example here. Oops. Oh. Maybe we will cut this. Okay, so let's look at our very simple example here. So we're going to make that same GET request that we made before, only the browser will actually take care and follow that 301 for us. We'll get a response. So here is a HTML page. It's got an embedded script. It's got an empty body, so there's nothing here to start with. Then the script will run. It will use fetch to make a GET request against this URL. It has this header. There's a lot of standard headers. I should probably cover those at some point, but I don't think they're relevant to today's lesson. In this one, we're saying we want to get JSON back. So then we're going to, this is promises, fetch, then callback function for the promise. So once we get a response, then we're going to turn it into JSON. Then we're going to create a P element. We're going to put the content of the joke inside the P element, and then we'll attach it to the body. So if I load this page up, I should get a joke that came from this website here. And let's see if that is actually true. Uh-oh. No, this is curious. Blocked by cores. Interestingly enough, it was not failing on Windows Chrome. So I will cut this out, but we're going to do a little bit of magic. Okay. Like magic, a lot of time has passed, but you don't know that. Cores is definitely beyond the scope of what we need to cover here. So I open up fetch.html, makes the request, and I get back my dad joke. In fact, I can even inspect it and I can see that that first request was made. Internal redirect. Chrome is just saying, hey, you've already tried to go there, and I know for a fact that it's already not going to work. So go here to the HTTPS. We go to HTTPS. We get back at 200. I didn't talk about status codes. So the response is identical to the request in the protocol, but it also has a status code. That's definitely something that you'll learn as you use HTTP, but not something we need to know about right now. And then the response body itself is the actual joke. So, haha, very funny, hilarious. Okay, flaws. Yes, HTTP has flaws. People often talk about performance as a flaw, and they'll say you need to use raw sockets for performance. Admittedly, ASCII is not perfect. There are more concise ways of doing requests, but then you're usually talking about something that is less generic, and you end up oftentimes thinking HTTP can't possibly work for me because it uses this weird complex ASCII header, which is just so inefficient. I'm going to come up with my own header dedicated to my own set of messages. And you start there, and then you think, oh, I need another message, I need another message, I need another message. 6 months passes, you forgot you ever thought about using HTTP, and then you realize, yeah, I hate that I'm always having to come up with new opcodes and things like that for new messages. I'm just going to come up with a protocol that's very generic and can work for a lot of different messages. And 3 years down the road, you have reinvented HTTP. HTTP performance is actually pretty good if you need to do something screaming fast, then maybe HTTP is too slow for you. A much bigger flaw is that HTTP is one way. So remember I talked about there's a client and a server. Well, HTTP is a request response protocol. Your client is going to send a request to your server will send back the response. There's no way for the server to send a message back to the client. Number of workarounds and clumsy things you can do. Loosely, they tend to be called Comet or reverse AJAX or things like that. Actually, for a long time, they're just called AJAX, even though that's not what it was. But anyway, yeah, like this example here, long polling, you make an HTTP call, and the server just sits there, doesn't ever respond to that HTTP call until it has data to send back. That has flaws like your server has to hold open this TCP connection, and you have to hold open a TCP connection from your available HTTP connections pool and things like that. Actually, I think all the solutions also have that flaw. So anyway, the workarounds were inconvenient. And then people will complain that HTTP is either too generic or too specific. So your soapbites will argue that HTTP is too generic. There's just too many ways that you can encode something into HTTP. SOAP, on the other hand, you can create a document, they call it a WSDL, that describes exactly what your API is. So you can start with, here's my class. You can automatically from that class generate a WSDL, and you can automatically from that WSDL generate your HTTP API. So you never have to worry about URLs or URL mapping or which method am I going to use? Is it in the query parameters? Is it in the entity body? We've solved all of that. There's just one way that you go from class with methods to HTTP API. So your soapbites would argue it's too generic. Too specific, your WebSockets folks will argue that HTTP is too specific. I have to follow this kind of rigid structure, and this kind of ties back into the performance thing where I have to use this clunky HTTP header and things like that, and I just want to go back to the old days when I had a stream of bytes going back and forth. So, fixes. There's two main, I'm not sure alternatives is the right word, but other approaches that the browser will give you that you can use, which will enable two-way communication. There's server-sent events. This is actually built on top of HTTP. It's basically you make an HTTP call, and the response that comes back follows a certain set of rules, and it just never completes. It just keeps going and going and going and sending more and more and more data. So the nice thing is that it is built on HTTP. It's going to look just like HTTP. You don't have to do necessarily any extra work on certain layers inside of your web server to get it to work. And it works pretty well. It doesn't get as much popularity and cool kids talking about it as the other alternative, which is WebSockets. So WebSockets, they start with HTTP, but then the connection actually goes into a non-HTTP mode. So this is not really HTTP, but it's given to you by the browser. So the browser finally got tired of people complaining about performance and HTTP being too specific, and they said, fine, here is that stream of bytes that you have so lovingly asked for. Have fun. So WebSockets is an API that's given to scripts, so your browser will allow you to use this, and it looks a lot like TCP sockets. It's not exactly the same, but pretty darn similar, and you're just going to be sending streams of bytes back and forth. And obviously for both of these, you're going to need support on both the client inside your script and the server. And both of these are only things you would see being used from JavaScript. There's no HTML tags or browser actions that are going to trigger server-side events or WebSockets calls. And that's pretty much it. So at this point, we have our rules of engagement for web server development. We have to live inside the constraints that our browser gives us. And we've kind of talked about what those are. We've got HTTP, HTML, WASM, JavaScript, CSS. These are tools that the browser gives us, and we have to use these tools to create web applications, which is what the rest of these presentations are going to be about, because from those tools, we have hundreds of different approaches, different architectures, styles. There's just a whole lot of variety out there. All of them are going to be built on these tools. These are our building blocks. Bonus points if you get the reference. All right. Thank you.